So we're now in chapter 4, and before we start this lesson, what I want you guys to do is I want you to just read this paragraph here, and just kind of go through and read this section, even read this entire section right here. So, pause the video, you guys have your packet, and just read that. I'm not going to read it on the video, it's going to take too long. So, pause for a minute, and go through and read that. So, hopefully that made sense. And essentially what's happening is we're saying, with these implicit equations that might look like this with an x squared and a y squared, we can't really solve it for y and isolate the y, but we can still use calculus. We still can take the derivative of this. And again, the difference between, y equals square root of 25 minus x squared and y equals plus or minus is, basically the difference between the one being a function with one x and one y and the other being not a function. This one's actually a circle. And so that's just something to watch out for, right? And so we're going to go and we're going to take the derivative of each of those two. And before we do that, though, I do want to really quickly just talk about chain rule. And actually, so far, anytime we've had something like the derivative of 3x, like if I have 3x, when we've done the derivative, we've actually just called it 3. But technically, what's happening is that we actually do have to do 3 times the derivative. This would be like our box, right? The derivative of x. Now, what's the derivative of x? Is just 1, right? dx, basically, like you can see, like dx over dx is just 1. But the reason this is very important is, so, I haven't really ever asked you to write that because it would be a waste of our time. But the reason that's important is that dy dx is not 1, right? dy dx is just dy dx. It doesn't simplify. And so we're going to call that implicit. Whenever we take the derivative of y, we're going to have to multiply by this dy dx term. And so we're going to kind of get there. So that's just a little bit of a head start. So we're going to look at both of these. So this is going to be the explicit version. And for our explicit version, we're going to be using y equals 25 minus x squared. So we're going to start off with y equals. Now I'm going to rewrite this as 25 minus x squared to the 1/2 power. And this is just a circle, but this is the top of a circle. So if this was 5 and negative 5, this is the top side of the circle. Right? The bottom side would be, if I put a negative in front, that would give us the bottom side. But if I just have the positive side, then it's the top side of the circle. So we're going to use the dy dx equation. So we're going to do dy, or notation, dy dx equals 1/2 times 25 minus x squared to the, minus x squared to the negative 1/2 times negative 2x. Now, if you wanted to use our shortcut that we've been using, you can absolutely use that shortcut, which is the 1 over 2 square root of 25 minus x squared times negative 2x. That shortcut is probably a little better to use. The 2's cancel out, and so on the numerator we get negative x divided by the square root of 25 minus x squared. So that's going to be what our dy dx is. So that's how we've been doing these. We've been doing these explicitly, solved for y. Now, if we want to do it implicitly, what's the difference between implicit is we may no longer have a function, right? If we were going to graph x squared plus y squared equals 25, that's actually the full circle. So I'm actually going to do this in another color so that we can just kind of differentiate between the two. So implicit, right, was when we had it not solved for y. And this would be the entire circle, negative 5, 5, so we get 5, negative 5. And so this is the entire circle. And so it's not a function, and so it's a little bit different. So the way we do implicit is we're going to start off with the full equation. So we're going to write out x squared plus y squared equals 25. And we're going to just write in d dx. So we're going to take the derivative with respect to x of every single term. We're going to write it anywhere where you see a plus or after the equal sign. So we're going to write d dx everywhere. So we're going to take the derivative with respect to x. Now, technically, the derivative with respect to x squared, and we're not going to write this out, so just kind of watch what I do first because I'm going to erase part of it. But technically, it's 2x, and then the chain rule, what I was saying, would be times dx dx. Now, what's dx dx? It's just 1, so we're not going to ever write that. Then plus, now this is where we are going to write it. We're going to write plus 2y, and this is where we're going to do times. The chain rule would give us dy dx. Okay, and then the derivative of 25 as a number is 0. So what you kind of have to just remember is that anytime we're doing a derivative with respect to x, you just want to compare the variables. I have an x, and I have an x, so I don't need to write dx dx. It just, it goes away. But if I have a y as my variable, I'm doing a derivative of y, and with respect to x, then we need to write in dy dx. So anytime it's a different variable from x, then we're going to write in that dy dx. Or, do whatever the variable is, dx. Okay, now we're solving for dy dx, right? That's what we're trying to do here. We're trying to isolate dy dx because we're trying to take the derivative, and dy dx is the derivative. So I'm going to subtract 2x from both sides. We get 2y dy dx equals negative 2x. Then we're going to divide 2y to both sides, and our 2's will cancel. And so we get dy dx equals negative x divided by y. And I want to kind of compare this really quickly because if we look at what was y actually equal to? What was our y equal to? Our y was equal to sort of 25 minus x squared. Now, in this case, actually, for the implicit, if we solve for y, we would get plus or minus the square root of 25 minus x squared. But if we look down here, this was for the positive case. So essentially what the implicit is doing is it's actually the same thing, right? Like, if we replace y with plus or minus 25 minus x squared, it's almost the exact same thing, except that the implicit one will give us both the positive and the negative case. It works for the function. Now, we're not going to replace that. We're going to leave it as y. Okay? But I just wanted to point that out and kind of kind of note that, is that, we're going to leave it as negative x over y, but just looking at the similarities between those two. So we're going to look at this circle, and we're going to first find the equation. Now, I know we're not great at this because this is something we skipped in Math 3, and it's not something you necessarily need for calculus, but I do want to teach it to us and make sure that we're kind of comfortable with it. So any equation of a circle is always x minus h squared plus y minus k all squared equals the radius squared, and where h comma k is our center, and then r is our radius. So this is something that you may have done in Math 2. You guys might have skipped it. Hopefully you did in Accelerated Math 2. But first we're going to go in and we'll find our center. Our center looks like it's at 3, negative 2. So that means we're going to have x minus 3 squared plus now y minus negative 2. That's going to turn to plus 2 squared. And our radius is 1, 2, 3, 4, 5. So that's our radius is 5. So 5 squared will become 25. So x minus 3 all squared plus y plus 2 all squared equals 25. Now if we wanted to implicitly take the derivative of that, what we're going to do is we're going to write x minus 3 squared plus y plus 2 squared equals 25. And then we're going to go in and write d dx for all three of these. So d dx, we're taking the derivative with respect to x of each term. Now this is chain rule, so we're going to bring the 2 down. Then times x minus 3 to the first power times the derivative inside is 1. Then plus again chain rule, 2 y plus 2 to the first power times 1. But then we also need to do times dy dx, right? The 1 is because it's something squared, it's not just x squared or y squared. And the derivative of 25 is 0. So this gives us, I'm going to leave it factored. So this gives us 2 times x minus 3 plus 2 times y plus 2 dy dx equals 0. And there's a shortcut, and you'll kind of learn the shortcut as we go. The shortcut is basically that anything without a dy dx, so anything without a dy dx is going to go to the numerator, and it's going to flip signs. And then anything near a dy dx is going to go to the denominator, and the sign's going to stay the same. And so I'll show this like kind of the long way, and then I'll do that by hand. So the long way would be subtract 2 times x minus 3 to both sides. So we get 2 y plus 2. If you wanted to cancel out your 2's, by the way, you could have canceled out the 2's since there's a 2 in every term. And divide both sides by 2 times y plus 2. And so we get dy dx equals negative x minus 3 over y plus 2. Now, I got rid of the 2's. And another thing, like on the AP test, they might even write this as negative here, x minus 3 over y plus 2, and kind of drop the parentheses. But know that that negative does distribute to the entire x minus 3. So flip both when you write it in the front like that. Now, kind of looking at my highlights, what I said was, right, this yellow term is going to go to the denominator, and the green term without the dy dx is going to go to the numerator and flip signs. So as you get pretty good at these, I usually actually just kind of skip the subtracting step and the dividing step, and I just jump straight there because I remember that shortcut. Is anything without a dy dx is going to switch signs and be in the numerator. Anything with a dy dx is going to go to the denominator. So just a little bit of a shortcut. Now, if we wanted to find dy dx at each of these points and then kind of draw a tangent line, we can do that. And now, to plug in, though, we need an x and a y value. Because remember, what is our equation? Our equation is negative x minus 3, negative parentheses x minus 3 over y plus 2. So the way that we write this is we would write dy dx at, this means like evaluated at 0, 2 is equal to, and we just plug in. So negative parentheses 0 minus 3 over 2 plus 2. So that's negative 3 turns to 3 over 4. So that's my slope. So at the point 0, 2, let's find the point 0, 2. So 0, 2 is right here. My slope is up 3, up 1, 2, 3, over 1, 2, 3, 4. I can also go down 3, left 4. So that's the equation of that's how I draw my tangent line. Okay, next one is for 3, 3. I'm going to just switch colors so we can kind of match up. So we're going to write dy dx, again, at 3, 3 is equal to negative parentheses 3 minus 3 over 3 plus 2. That's 0 over 5, and anything with a 0 in the numerator is 0. So that's a horizontal tangent line. Right, so just, you don't need to necessarily write this, but just kind of recognizing anytime you have 0, you have a horizontal tangent. So at 3, 3, that kind of makes sense because it's at the top of my curve. A slope of 0, right, that's just going to be like that. Okay, another new color, we'll go with blue. So 8, negative 2. So we're going to write dy dx at 8, negative 2. So 8 is our y value, negative 8 minus 3 over 2 plus 2. Oh wait, negative 2 plus 2. Right, y is negative 2, negative 2 plus 2. So this gives us negative 5 over 0. Now, when we have 0 in the denominator, that's undefined. But we want to remember that 0 in the denominator as a slope is like a vertical slope, right? That's what a vertical slope looks like, is like up 5 over 0, up 5 over 0. So this is a vertical tangent line. So normally we would have said this was not differentiable, right? And it technically is not differentiable. But we can still draw a tangent line. So at 8, negative 2, technically the derivative is undefined, it's not differentiable. And why? Because it makes a vertical tangent line. Okay, next one, 3, -7. So I'm going to speed this up here and just kind of talk through these. So as we plug in the next slope, we get a 0, which is a horizontal tangent line again. Then after that, we're going to plug in the slope at 6, 2, and we'll get another slope of, this time, -3/4 instead of positive, which makes sense when you graph the point. It's kind of symmetrical on the opposite side of the circle to our first slope, which was 3/4. So that's why it's -3/4. And you can graph that in just by going down 3/4. Then our next one we get is 5/0 again, which is another one of those vertical tangent lines, right? And that's symmetrical to our other vertical tangent line. And finally, at 6, -6, we plug that in and we get 3/4 again. And so we can, plot the 2 points up 3/4 and draw on that tangent line. So there's that. Our first step is always to write dy dx in here, or ddx, or just ddx, the derivative with respect to x for each term. So that's going to be 2y, but anytime we have a y, times dy dx. That's the biggest thing students forget. The derivative of 2x is 2, and the derivative of 3y is 3, but then times dy dx. Why times dy dx? Because we need to multiply by that anytime we're doing it with y. So I want to move everything with dy dx to one side and anything else to the other side. So 2y dy dx minus 3 dy dx equals 2. Now, we haven't done one like this where we just have dy dx, but what we're going to do is we're going to move everything with dy dx to one side, everything else to the other side. And the reason we do that is now we can factor out a dy dx term. And we end up with 2y minus 3 equals 2, and we can divide both sides by 2y minus 3. And so those cancel, and we get dy dx is equal to 2 divided by 2y minus 3. You cannot cancel out those 2's because of the 3. There's not a 2 in every term. Okay. Next one, we'll do the same thing. Let's use another color. So take the derivative with respect to x of every term. And I always write this in because it helps me to remember to do that implicit, that multiplying. So the derivative of 2x is 2. The derivative of e to the y is e to the y, but then times dy dx, right? It's the same thing like e to the x is e to the x, but then because it was with a y, times dy dx. Equals 2x minus the derivative of y squared is 2y dy dx. So we're going to do the same thing. We're going to move everything with dy dx to the left side, everything else to the right side. So we're going to have e to the y, dy dx. Now we're going to add the 2y over, right? Basically the signs switch when you move them over. So plus 2y dy dx. You don't have to show the adding over, just know that your signs switch. Equals 2x, then the positive 2 when we switch it over becomes negative 2. Now you're going to factor out a dy dx. E to the y plus 2y equals 2x minus 2. And again, you don't have to show the dividing step. So dy dx equals 2x minus 2 divided by e to the y plus 2y. And if you wrote y first, if you wrote like 2y plus e to the y, that's okay. If you factor out a 2 in the numerator, that's okay. So there's our answer there. Okay, this next one's going to be a little bit harder. And that's because we see that we have x times y. So this is going to be x times y. That's going to be our product rule. And product rule is a little bit tricky the first time you see it. But once you get the hang of it, it's not too bad with implicit. So what does product rule say? It says to take the derivative of the first, leave the second alone, and then add on the derivative, like leave the first alone, the derivative of the second. So we put the d dx everywhere. But for product rule, we only do the times dy dx when we're doing the derivative, the y part. So again, the first rule says take the derivative first. What's the derivative of 2x? It's just 2. We don't multiply by dy dx because it's 2x. Then we leave y alone. Again, we don't multiply by dy dx because we were leaving y alone. Now plus, now we're going to do 2x, leave x alone. The derivative of y is going to be 1. But then because we did the derivative of y times dy dx. So again, just going over that one more time. We did the derivative of 2x part was 2. We don't multiply by dy dx because it was an x. And we leave y alone. We don't multiply by dy dx because we were leaving it alone. Then we do leave 2x alone. The derivative of y is 1, but because it's a y times dy dx. Okay, derivative of 3y squared is 6y dy dx. And the derivative of 2x is 2. So this is 2y plus 2x dy dx equals 6y dy dx plus 2. We want to move everything with the dy dx to the left side, everything without to the right side. So 2x minus 6y, oops, forgot the dy dx. 2x dy dx minus 6y dy dx, right? The 6y changes signs when it moves sides, equals 2 minus 2y, right? The 2y changes signs when it moves over. Now we can factor out a dy dx. And when you get pretty good at these, I don't even write the factoring step. I just realize that, the 2x minus 6y part is going to divide. Okay, so now we're going to divide it. And again, I don't show the dividing step. 2 minus 2y divided by 2x minus 6y. Now you can factor out a 2 from the top and the bottom, or you kind of see that a 2 is everywhere. So we're going to cross out a 2. Now when you cross it out, make sure you put a 1 in its spot. So this becomes dy dx equals 1 minus y over x minus 3y. Okay, don't do this whole question right and then mess up because you forgot to write in this 1. I've seen a lot of students do that where they cross out the 2 and they just move it, it's gone. Make sure you put a 1 in its spot. Okay. Then our last one for this set, we're going to do d dx in each spot. So in this case, the derivative of 5x cubed, 15x squared. The derivative of 3 is nothing, it goes to 0. Equals 2 dy dx, and then whenever you see an x and a y together, that's going to be that product rule. Now, be very careful. Okay, what I want you guys to do is really be careful about this negative sign. You need to group the negative sign in with your product rule, and then just write plus. Don't put minus, put plus. Right? And the reason for that is we're grouping it with the negative sign. If you want to put minus and not group it, then you need to literally put the whole entire thing in parentheses, and that gets weird. So I always put plus, but then group the negative 3 with it. So the derivative of negative 3x squared is negative 6x. Leave y alone. Then another plus, and then leave negative 3x squared alone. The derivative of y will be 1, but then dy dx. Okay? And if I have that negative in both, I'm okay. The other thing I've seen students do, and this works too, if you had wanted to, is you could have not grouped the negative. You could have just done the 3x squared and the y, but then put both of these as being negative. So if both of those were negative, then the insides would have been positive. But either way you do it is okay. So the way I always do it is I group the negative in, and then just make my product rule both have pluses. So this becomes 15x squared equals 2 dy dx minus 6xy minus 3x squared dy dx. Now if you're really good at math and you're comfortable, you move the 6xy over, because you're going to have dy dx both on the right side. But if you want to put it always on the left side, you can always put it on the left side. So that's what I'm going to do. So I'm going to just move the 2 dy dx over, make it negative 2 dy dx. Move the negative 3x squared over, make it positive 3x squared dy dx. And then move the negative 15x squared over, make it negative 15x squared minus 6xy. So basically, I put everything with the dy dx to the left, everything without to the right, and if they're going to switch sides, they have to switch signs. Now we can factor out our dy dx. That gives us negative 2 plus 3x squared, and we may even change this to be 3x squared minus 2, just like reverse the order, equals negative 15x squared minus 6xy. Now we're going to divide. And one thing that I do want to point out with this is that when we divide this, we do want to factor out that negative, okay? So we don't want to have a negative with our... So what's going to happen is, we can just factor out negative, right? We don't want a negative with our biggest x term, plus 6xy, divided by... And I'm just going to switch these. Instead of writing negative 2 plus 3x squared, basically I'm just going to put the 3 in front, right? Because in math, a lot of times we put the biggest x first. So I'm going to put 3x squared minus 2. Okay, and that's our answer. Now, I do want to just point out, because I've seen this happen on AP multiple choice. What if this wasn't here? But instead, the choice was 15x squared plus 6xy divided by 2 minus 3x squared. Would this be the same thing? And actually, yes, it would. So what happens in math is you can always flip your signs if you add a negative factor outside. So you can always flip them. So what this, basically the intermediate step would have been to write negative, parentheses 15, x squared plus 6xy. And because we're basically just trying to get rid of the negative sign, if we factor out a negative, I said we can flip those two. So 2 minus 3x squared. I have seen this done on the AP multiple choice, that's why I'm showing it. Now the two negatives can just cancel out to become positives. And so that's what happened there. So just be aware of that, is if you ever see a choice, like an answer choice, where you had a negative and they flip it, it's kind of the same thing. And you can just kind of work that out. Okay, moving on, just getting a little bit harder. For what values of x will the curve x cubed plus y cubed equals 4xy plus 1 have a horizontal tangent? So what do we know about a horizontal tangent? We know that that's when the slope is 0, when the derivative is 0. Now what's another name for slope? Is derivative. So when, instead of writing m equals 0, we can say when dy dx equals 0. So we're going to say x1, y1, and m, because it's a tangent line, we know m is 0. Now, they only wanted the x, so we're not actually writing the tangent line, so just be aware of that. We're not going to actually finish it, we're just going to solve for x. But because it's implicit, for implicit, right, it says values, we're going to have more than one answer. Right, because it was implicit, it wasn't a function, so that's okay. So, we're going to have x cubed plus y cubed equals 4x plus y plus 1, and I'm going to just rewrite this. And then I'm going to write in, that we're taking the derivative with respect to x of each term. So the derivative of x cubed is 3x squared. The derivative of y cubed is 3y squared times dy dx. And here we're going to have 4x times y. That's a product. So we've done this a couple times now. The derivative first, the 4x part is 4. We're going to leave y alone. We don't put a dy dx here because we did the derivative of x part. Then plus, we're going to leave the 4x alone. And the derivative of y is 1 dy dx. And the plus 1 is 0, it goes away. So we have 3x squared plus 3y squared dy dx equals 4y plus 4x dy dx. Now, what's going to happen here is we want to move all of the dy dx's to one side, all the x's to the other side. So we have 3y squared dy dx minus 4x dy dx equals negative 3x squared plus 4y. Factor out a dy dx. And then divide. we get negative 3x squared plus 4y over 3y squared minus 4x. And if we wanted to factor out a negative from the numerator, we could, if a question like had that as an option. And this is where it's going to get a little bit weird, and where we're actually going to need to use our calculator, is we know that we have a horizontal tangent at, this point. So we know that the slope is 0. So what we can do is, instead of writing dy dx, right, instead of writing dy dx, we're going to set that equal to 0. So we're going to say 0 is equal to negative 3x squared plus 4y divided by 3y squared minus 4x. And for 0, it's only ever the numerator, right? When the numerator is 0, it goes to 0. Remember, when the denominator is 0, it goes to dne. So what we can say is negative 3x squared plus 4y is equal to 0. Now, I have two variables, so I can't solve this. But remember, if I have two variables, I always need two equations. So this is my first equation, and this is my second equation. And on a lot of these, what you'll actually do is you'll solve for y. So like here, if I solve for y, I'd get 4y equals 3x squared. And that would give me y equals 3/4 x squared. And so then what I can do is, anywhere I see a y, I could plug it in. So I could plug in 3/4 x squared, and we could solve this by hand. 3/4 x squared, and you could solve that by hand. This one's a little bit too hard to solve by hand. And so what I'm going to show you, I know we haven't fully used our calculators yet, but we're going to start really using them. And so I want to show you guys kind of how that would work. And so a really cool option on our calculator is in menu, in algebra, we have solve system of equations. Oops. Now, it's going to ask us when we go there, it's going to ask us, oh my goodness, menu, let me do this without using my mouse. Algebra, solve, system of equations. Now it's going to ask us, are they a system of equations or are they a linear system of equations? And that's really important. These are not linear. Linear is like 2x plus 3y equals 6. If we have a squared, we have a cubed, which we do, they're not linear. So we want to pick that system. So we have two equations, and the variables we're using are x and y. We're going to hit enter. Now, it puts in two boxes, and it just wants us to type in our equation. So our first equation is the original one. We have x cubed plus y cubed equals, okay, got lost. Oh my goodness. Okay. There we are. X cubed plus y cubed equals 4. Now, be careful. If you write 4xy, you're going to get this question wrong. This is a big, big mistake students make. If you write 4xy, what your calculator, it doesn't realize, it knows x is different from y. But it's actually going to treat x, y together as a third variable. Okay, so what you need to do, you need to be very careful, is you need to always put a times, a multiplying, in between your x and your y. If you want to even put it in between the 4, that's great. So 4x times y plus 1. That's very, very important. Then in the second box, we're going to put where I had number 1. You could solve it for y equals 3/4 x squared, but I'm going to just put where we had number 1. So negative 3x squared, negative 3x squared plus 4y equals 0. And now we're going to hit enter. And it basically didn't, this is like the fraction version. If you want a decimal, which I think this is way too nasty, you're going to hit control enter, and it'll change these to decimals. So it gives us at x equals, basically here's the full point, 0.7697 and 0.444. And then, or at x equals 1.732 and y equals 2.2. And if we keep scrolling, that's it. So there were 2 points. So it gave us the x and the y value, but we didn't need both. We just wanted the x value. So I'm going to kind of write these over here. Let's go out to 4 decimals. If you don't want so many decimals, my calculator right now is set. Yours might be different. On 7, on document, if we go to number 7 and we go to number 2, there's this float. This is how many digits we have. Float 12 is a lot of digits. So if I change it to like 6, that's going to give me 6 digits. So if I go ahead and just hit control enter again, that's going to redo this with the less digits. It's going to be a little easier to see. So x equals negative 0.76, we want to go up to 498. Or x equals 1.7321. So those are my 2 x answers. Okay, again, I know we didn't do the calculator yet, but just kind of seeing that is helping us to get ahead a little bit. So now in terms of y, for what value would x cubed plus y cubed equals 4xy plus 1 have a vertical tangent? Now, what's a vertical tangent? That's when the slope is undefined. Where are we going to get the slope undefined? When the denominator is 0. So we don't have to redo the derivative. This was the same derivative. So we know that the derivative was negative 3x squared plus 4y over 3y squared minus 4x, right? That's the same derivative we had up here. If it's going to have a vertical tangent, though, basically what we're saying is that the slope is undefined, but what that means is we're going to take the denominator and set the denominator to 0. So we can say 3y squared minus 4x, that's going to equal to 0. So now, that's my first equation. My other equation was the original. So we can do the same thing we just did on the calculator, right? But we're going to change that second equation to be our denominator. So instead, the second equation is going to be the 3y squared minus 4x. And then I'm going to hit control enter to make sure I get that decimal. Okay, now, do go up here and just double check that there are only 2 values, right? Because there could be 3, there could be 4, we don't know. So 2.2502, that or is where the separator is, so we have 2, so that's good. So our x values are going to be at x equals 0.444, right, out to 4 decimal places, and 2.502. 2.2502 out to 4 decimals. So again, if your calculator isn't working yet, that's okay. I'll show you guys an alternate way of doing this, but when we get into class. But I really want us, if our calculators are working, I really, really want us to practice using our calculator and trying that on our own. So that is something that has definitely been asked on AP free responses, and you would want to use your calculator to help you solve that. So next up, this is where we take it a step further, okay? So normally I would have split this into 2 days, and if you want to split this into 2 days, can I take a break here and go? But because it's fall break for us, we're going to do this all together in one day. But if you want to take a break, stop your video, stop your notes, and then come back to it, because this part gets a little bit trickier. And this is going to be to find the second derivative. So basically what we're going to do is we're going to do this process twice. So given the curve y squared plus 2y equals 2x plus 1, find the second derivative. So first step is going to be to take the derivative. So I'm going to put in the ddx, 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 and ddx. And so we get 2y times dy dx plus 2 times dy dx equals the derivative of 2x is 2. So we see a 2 everywhere. If you want to, you could cancel out now and make them all 1s, but I'm going to wait. So dy dx times 2y plus 2 equals 2. Divide, we get dy dx equals 2 divided by 2y plus 2. And now, I'm going to cancel out my 2 everywhere, but put a 1 in its place. And so we get dy dx equals 1 over y plus 1. Now, this is where it's going to get hard, okay? So this is where it's going to get a little bit hard. I like to put a little dash under to kind of separate myself. And what we're going to do is we're going to take the second derivative. Now, the way you take the second derivative is we do that same process of put a ddx on the left side, and we're going to put a ddx on the right side, but we're going to kind of put it in parentheses. This is going to be quotient rule. So we're going to do quotient rule on it. Now, on the left side, we're going to just write d squared y dx squared. That's the notation for second derivative. I know it's a little bit weird, but the squared always goes on top right after the d, and on bottom after the variable. So just kind of learn that. That's how we write second derivative. On the right side, we're going to do quotient rule. So low, y plus 1 stays alone. We don't put dy dx because it's staying, right? Y plus 1. Now, low d high. What's the derivative on top? What's the derivative of 1 is 0. Minus high is 1. D low, the derivative of y plus 1 is 1 times dy dx, because there's a y there. We were doing the derivative of a y. All divided by y plus 1 squared. And so we end up with d squared y over dx squared equals negative dy dx over y plus 1 squared. And this is where it gets a little bit weird. You cannot have dy dx in your equation. Okay? You can't have dy dx in your equation. But what did we know that dy dx was? So if I kind of get rid of this blue, we knew that dy dx was 1 over y plus 1. So what we're going to do is we're going to take this and we're going to plug it in wherever we see dy dx. So this is going to become negative 1 over y plus 1 all over y plus 1 squared. Now you cannot have a fraction inside of a fraction, so you multiply by the denominator. So we're going to do times y plus 1, those cancel, and times y plus 1. And that's going to go to the third power. So we're going to get d squared y dx squared equals negative 1 over y plus 1 cubed. Now, this has appeared on the AP free response, so I don't want to say it doesn't matter, because it can actually be a lot of points. But most of the time, this second derivative is like a single point, maybe 2 points on the exam. So you definitely need to know how to do implicit. Like everything up here that we did, like these 4 examples, you absolutely for sure need to know how to do. And then on certain AP exams, this horizontal tangent, vertical tangent, and the second derivative part has shown up on a free response. And so it's something that we should be comfortable with. But generally speaking, those are, very, very small portions of the overall exam. So if this last part, this last page was really, really difficult for you, just practice it. We'll get some practice, we'll get better at it. But don't stress over it. It's not a huge portion of your test. So let's try it again. So same process, right? We're going to do that second derivative, so we're basically going to do it twice and plug in. So first is just doing it normally. So derivative x squared, 2x. Derivative y squared, 2y times dy dx equals derivative 1 is 0. So let's move the 2x over. 2y dy dx equals negative 2x. And if you want to cancel out your 2's, you can. Divide dy dx equals negative x over y. Okay, I'm going to put like a dotted line. Right, and we're going to do the second derivative. So when we do the second derivative, we write d squared y dx squared equals, now low is y. We don't put dy dx because we kept it the same. D high is negative 1. We don't put dy dx because it had an x. Minus high. Then for d low, we're going to put dy dx. Right, 1 dy dx. The derivative of y is 1. All over y squared. So what we're going to do is, where we see the dy dx, we're going to plug in negative x over y. So it's going to give us negative y. Now, minus negative x is going to turn into plus x times negative x over y, all over y squared. Right? So basically, I just did the negative times the negative made positive x, and then for the dy dx, we plugged in negative x over y. So now, what we're going to do is we're going to multiply everywhere by y. Now, times y. This goes for like this entire thing, right? Because this is all with a times. We write times y where we see like the separators, which is the plus and then times y. So here they cancel. We get negative y squared minus x squared over y squared. And that's a perfectly acceptable answer. However, generally on an AP exam, they're not going to want negatives with your exponents. They're probably going to want the x squared first. So they're going to probably factor out a negative and write this as x squared plus y squared over y squared, like that. They may even move the negative like out into the front and write that. So any of those three, I'll box all three of them. Any of those three is full credit on free response, whereas on multiple choice, you're going to want to just match it with what they have. So the last part of our notes, and I know this is already a really long video, but it is what it is. The last part of our notes is to do an example of a, I mentioned a couple times that some of the FRQs will have implicit, and so we're going to do an example. The really nice thing about most of these is most of these do actually tell us that what the first derivative is. They kind of give us the answer. So that first couple points is actually a very easy couple points because we're just, basically going to get that answer. So on A, what I'm going to do is I'm going to just rewrite the original. X squared plus 2x plus y to the fourth plus 4y equals 5. And then I'm going to just write in, and if you have different colors, you can use them. I'm going to write in ddx, 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 and ddx. So the derivative with respect to x, that's how we say that. So the derivative with respect to x of x squared is 2x. Plus the derivative with respect to x squared of 2x is 2. Plus 4y cubed times dy dx. Plus 4 dy dx equals 0. Now, if you want to do the super cool shortcut, you could actually just jump straight to the answer, which is, negative 2x minus 2 over 4y cubed plus 4. And I'll show you how to do that shortcut, but I'm going to do it the long way and then kind of show how I knew to get there. So what I'm going to do first is I'm going to move everything without and a dy dx to the other side, but it's going to switch signs. So 4y cubed dy dx plus 4 dy dx equals negative 2x minus 2, right? I move those to the other side. Then we're going to factor out a dy dx. We're going to get negative 2x minus 2 over 4y cubed plus 4. Now, everywhere I see a 2, but before I do that, I want to talk about how did I know that that was going to be what we end up with. So the way this works is kind of that whatever does not have a dy dx on the left side is going to switch to the other side and switch signs. So negative 2x, negative 2. And then the terms with our dy dx, those are going to become our denominators. So if you want to use that shortcut, you can once you get comfortable with these and just jump straight there. But make sure that you're really comfortable in getting the right answer every time. So next up, what we're going to do is we're going to cancel out a 2 everywhere, but put a 1 in its place just to make sure you don't forget about it. Or, if it's 4, divide it and put a 2 in. So this gives us equal to negative x minus 1 over 2y cubed plus 2. And if we look at the answer they want, it's almost that. We just have to kind of do the last step of factoring. So in the numerator, we can factor out a negative sign and change it to x plus 1. And the denominator, we can factor out a 2 and get to y cubed plus 1. And then just kind of box it. But the points here were to show, so the points here are really for our work. We're giving the points for the work in there. Right? We already know what the answer is. Okay, B. Write an equation for the tangent line at the point negative 2, 1. And on these, sometimes they'll give you both points, sometimes they won't. So just remember, x1, y1, and m. In this case, they gave me negative 2 and they gave me positive 1. But if they didn't give me 1, how would I get 1? I would take my negative 2 and I would plug it into the original where we saw x. The issue with these is they're harder to solve because they're implicit. So a lot of times they'll give you both. So in this case, they gave us both. So for our m, what do? We actually need to plug in both points. Normally, we just plugged in x into the derivative. But here we're going to need to plug in both points. So dy dx, remember we did this kind of towards the beginning of the lesson, at negative 2 comma 1 is equal to negative parentheses, negative 2 plus 1, divided by 2 parentheses, 1 cubed plus 1. This gives us negative 2 plus 1 is negative 1, and then negative 1 will turn it back to positive 1, over 2 times 2 is 4. So our slope is 1/4. Okay? So here what's going to happen is we're going to just do y minus y1 equals m times x minus x1, right? And we should end up with y minus 1 equals 1/4 times x plus 2. And there's our equation for the tangent line. And so I believe actually both of these first two are worth 2 points, which is a lot, because each question, remember, is worth 7. It's worth 9. So 4 out of 9 is almost half. So you got 1 point here for getting the correct slope, for getting the 1/4, you got 1 point. And then you also got 1 point for the final equation. And on the first one, you got your 2 points. Basically, I think you got 1 point for just doing the implicit, so you probably got 1 point for like this line right here. And you got 1 point kind of for the rest of it, for like basically getting to the answer. So, at this stage, honestly, even if you did nothing else, you're at a 4 out of 9, and that's on track for a 3. On the free response, if you get a 4 out of 9 on every question, you're really, really on track for a 3. So anything from here on is kind of bonus. So if the last C and D get a little bit harder for you, just think, hey, you know what? I know I could get 4 points on A and B. I'm sitting solid. Okay, C says find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. Now, you guys may need to add a second paper here, so we don't have a whole lot of room. So you may need to go out and get a second piece of paper. I'm going to try to squeeze it in, but if you need more paper, that's fine. So on C, find the coordinates of the 2 points. So it did give us, answer, and coordinates means the x and the y, where the line tangent to the curve is vertical. Now, where do we get a vertical tangent? Is when the denominator of the slope is 0. But, you probably want to write this. You want to write like dy dx equals undefined. That might be something really good to write. That might be worth a point. And when that happens is when 2, the denominator 2 times y cubed plus 1, when that denominator is 0, that's when the slope is going to be undefined. So for sure, that's going to be worth 1 point. Okay, just even writing that is going to be worth 1 point for you. Okay, so now what are we going to do? Divide both sides by 2. Y cubed plus 1 equals 0. Y cubed equals negative 1. And so we're going to cube root both sides. Now the square root of negative 1 doesn't exist, but the cube root of negative 1 is negative 1. So that is going to exist for us. Okay, so that was our first step. Now, to get the other one, and kind of, something that could help you out, you could put x1, y1, and m. We're not actually writing the full equations, but this can always help us. We know that the slope was undefined. Now we know that our y1 is negative 1. How are we going to get our x1? We're going to plug that into the original. So that's kind of writing the x1, y1, m sometimes helps me when I'm like, wait, what do I do next? So we're going to take this, we're going to plug it into our original equation. Our original equation was the x squared plus 2x plus y to the fourth, but instead of y to the fourth, we're going to put negative 1 to the fourth, plus 4y. Instead of 4y, we're going to put 4 times negative 1 equals 5. This is x squared plus 2x. Now y to the fourth, negative 1 to the fourth is going to be plus 1 because it's a positive exponent. Minus 4 equals 5. That gives us x squared plus 2x minus 3, and then we're going to subtract the 5, minus 8 equals 0. And so here we can factor, and we can go with x plus 4 and x minus 2. So that's going to give us x equals negative 4 or x equals 2. Now, basically what this would be if we were writing like the equation of a tangent line, we would have two x1s, and then y1 is negative 1 in both cases, and m is undefined in both cases. So one of these is negative 4, and the other one is 2. But they didn't ask us to write the equations, they just asked for the coordinates. So our coordinates are negative 4, comma, negative 1, and 2, comma, negative 1. Both times we're going to put in negative 1 for the y value. Now, if you want to write out a little sentence and say the vertical tangent lines are here, great, but, you don't have to. So just going with the points breakdown, since I was kind of talking about that, we had 1 point for setting the denominator to 0. We had 1 point for plugging in, so for this part right here, plugging in negative 1. And then we had 1 point for our answers. So those were 3 points. And then our last one, and we'll see if I can squeeze this in right here, was, is it possible for this curve to have a horizontal tangent at the points where it intersects the x-axis? So where it intersects the x-axis. Now, that's a little bit hard, but what we can kind of think about is, where does this graph have a horizontal tangent? So first of all, it cannot be at y equals negative 1. Right? Why can it not have anything at y equals negative 1? Because that's the denominator. That wouldn't work. That's not in the domain. But where would it have a horizontal tangent is when the numerator is 0. So negative x plus 1 when that equals 0. Right? Because when our slope, when our derivative is 0. So remember what I said before is basically like the numerator to 0. That would be for a horizontal tangent. And the denominator equals 0. That's for a vertical tangent. So that's something we just need to kind of remember. Right? So if we solve for this, we get negative x equals negative 1 or x equals to positive 1. Did I mess that up? Yeah, I messed that up. This is my fault. It was negative parentheses x. I forgot that parentheses. So don't forget the parentheses like me. So negative parentheses x plus 1 is equal to 0. So that's negative x minus 1 equals 0. Negative x equals positive 1 or x equals negative 1. Okay? So you got 1 point just for solving for that. Like that was worth 1 point. And again, remember what I said is your goal here, 4, 5, 6 points is huge. So if you can literally just realize, hey, what do I do with a horizontal tangent? I set the numerator to 0. Even if you don't finish this problem, you're like, I have no clue what to do from here. I'm stopping. You still got a point. That's awesome. Same thing even on the last one. If you messed up your factoring, you did good. Now, is it possible for us to have a horizontal tangent here? Okay, well, let's just try plugging it in. So the curve would basically, it wanted to know, is it possible for us to have a horizontal tangent where it intersects the x-axis? Well, where does it intersect the x-axis is when y equals 0. So we could do one of two things. We could either plug in negative 1 and solve for y and see if it's 0 or not, or we could plug in negative 1 and 0 and see if the equation works. So I'm going to do the second thing. So I'm going to do is anywhere I see an x, I'm going to plug in negative 1. Right, and the reason I'm not going to do that is y to the fourth is going to be really hard to solve for. So I'm going to be like, I don't want to solve for y to the fourth, so it's just asking, is it possible when it crosses the x-axis? I know that basically crossing the x-axis means that y equals 0. So this was definitely a tricky question. So if you, had like, hey, Mr. Yu, I can never do this on my own, it's not a big deal. 99% of the students who took this exam didn't get this last point. Okay, then plus 4 times for the y we're going to put in 0 equals negative 5. So that gives us 1 minus 2 plus 0 equals negative 5. That gives us negative 1 equals negative 5, which is false. So because this is false, we would say, no, the curve does not have, or cannot have, maybe, cannot have a horizontal tangent at, where it crosses the x-axis. And you don't need to show any, say anything else because you just showed your work. You showed that, you solved x equals negative 1, that's when the slope is 0. And y equals 0, that's when it crosses the x-axis. And you proved negative 1 does not equal to negative 5, that's a false statement. So, again, that last point was definitely hard, but I think the first 8 points, honestly, were not too bad on this question. Okay, so that was good practice. I know it's a super long video, but take a little break, and then go ahead and get started on your day 28 homework. You don't have to do everything today. If you want to split it up, you can, but just make sure that you're aware of your scheduling for this fall break.